Okay, in this presentation we're going to look at the normal distribution and some questions relating to the normal distribution. So it starts off with the first question here, the first part of it. Apple juice is dispensed by a machine into cartons. The nominal value of apple juice, the nominal volume of apple juice in a carton is 1 litre, which is 1000 millilitres. The actual volumes of juice put into the cartons can be regarded as being independently normally distributed, with a mean set at 1010. That's important there, 1010, and a standard deviation of 8. Okay, so find the percentage, this is part A, find the percentage or proportion in the long run of production of cartons containing less than the nominal volume. Okay, so X here is the actual volume of juice put into the cartons, and X is normally distributed with a mean of 1010 and a variance of 8 squared. Okay, and also we're going to use the standard normal distribution in answering these questions. So we would sort of say Z is normally distributed with a mean of 0 and a variance and standard deviation of 1. Okay, so we're asked for the probability of X less than or equal to 1000. Okay, so what we would do here is we would calculate a Z-score. So I'm going to put an added emphasis on Z-scores here. Okay, so essentially what the formula is, we have some value here, X, and in this case it's 1000. What we do is subtract the mean, which in this case is 1010, and divide by the standard deviation. So what we end up with is 1000 minus 1010 over 8, which is actually minus 10 over 8, and that gives us a Z-score of minus 1.25. Okay, so Z less than minus 1.25, or less than or equal to, like, if you're, it's a continuous distribution, so that's really not too important. Now, if you are familiar, I've sort of gone over this part here in not too much detail. I give the answer as 0.1056. Okay, now how I might go about doing that in a bit more detail is to say that if you're used to statistical tables, essentially that's how we would calculate it. The Z-score is minus 1.25. Here I'll just make reference to one particular approach, which is the complement rule, and this is, the symmetry rule. The probability of Z being less than minus 1.25 equals the probability of Z being greater than 1.25. Okay, which this is a value you should be able to look up very easily in the tables. That's called the symmetry rule if you're not familiar with it. Okay, anyway, the answer we're looking for here is 0.1056. Okay, so I'm just going to get rid of everything there just to sort of clean it up a little bit. Okay, so the answer we're looking for is 0.1056. Okay, so the next part is cartons of apple juice are often sold in packs of 6. Okay, write down the distribution of the total volume of juice in a pack of 6 cartons. Okay, and then find the probability that the total volume, this is actually part B as well, I should put this up here, but anyway, find the total volume of juice in a pack of 6. Find the probability that the total volume of juice is less than 6 litres, less than the nominal volume. Okay, and why is this less than part A? Well, so anyway, let X be the total volume in a 6-pack. Okay, and essentially what we're going to do here is essentially add up the means, multiply out the means. So we have 6 times the mean of one particular one, and then what we do is we add up the variances. Okay, essentially, actually, really correctly, we add up all the means and add up all the variances for a sum of random variables, or sum of normally distributed random variables. Okay, so essentially the means summed up and the variances summed up. So what we end up with is the Y, which is the sum of the 6-pack, is normally distributed with a mean of 6060 and a variance of 384. Okay, just as a remark, because what we're going to do is use a calculated Z-score again very soon, just to remark that the variance is 384. That means the standard deviation sigma equals the square root of that, which is 19.6. So that is the distribution. That is how we would sort of specify the distribution, okay, there. But what we're going to do now is find the probability of y being less than the nominal amount, which is 6,000 milliliters or 6 liters, okay. And what we do here is, again, we calculate the z-score. So 6,000 is our test value. The mean is 6,060, and the standard deviation, which I got here, is 19.6. So essentially what I get here is a z-score of minus 3.06, okay. So that's how I go from here to here, okay. And using statistical tables and the normal probability rules, such as the symmetry rule, that is the answer we get. And again, just to sort of restate the symmetry rule, there we go. Okay, and it's greater than 3.06. So this should be easily calculated, easily found using statistical tables. I'm being a little bit cavalier actually with regard to less than here and less than or equal to here. That's not. I should actually just keep it consistent. But just the fact that we're dealing with that's a mistake on my part. But the fact that we are dealing with continuous random variables means that it's much of a muchness. And in fact, this is what we're explicitly told in the question, okay? But actually, if you're using statistical tables, they are sort of formatted like that. And they would, the one I would use or recommend would actually work on the basis of less than or equal to. So it's just a little bit of a fudge there, okay? With continuous random variables, it's not too important. With discrete random variables, it is super important, okay? Also with approximations, it's very important. Okay. Now the probability is considerably smaller than part A, and in practical terms is because there will be a tendency for heavier and lighter cartons to balance each other out in terms of overall weights. It'd be very, very unusual to get 6 packs of juice that are all less than the nominal volume for one carton. So moving along, I'll leave that there. It's actually, I think I'd leave it. Move on to the next part there. There's a couple of other approaches you can take. So I'm just going to move on to the next part. A new and more accurate machine is available for which the volume of juice dispensed is normally distributed but with a smaller variance, a smaller standard deviation and hence variance, and the new standard deviation is 4 milliliters. Okay, so essentially what we want to do is see how much we can reduce the mean. By how much could the existing mean volume be reduced? Remember, the existing mean is 1010 and we want to reduce it to something without increasing the proportion of cartons less than the nominal volume. Okay, so essentially what we want is, essentially what we have here is some variable W. Okay, I'm going to call it W, and that is normally distributed with some mean that we don't know, but a variance of 4 squared. Okay, and essentially what we want to do is keep the variance or the probability of less than the nominal volume at the same amount as we had before. Okay, so essentially what we have to do here is work backwards. Suppose that the additional cost of the more accurate machine is $200 or $200, and the cost of the apple juice is $1 per liter. How many cartons of orange juice must be filled by the more accurate machine in order to justify the cost? Okay, so this is actually working with the z-score formula a little bit. So there I have it again. W equals is normally distributed with a mean of mu, which is what we want to find, and a variance of 4 squared. Okay, so this is how to express the proportion or percentage that is less than the nominal volume. Okay, and if we were to work it out using the z-score formula, this is how we would do it. Okay, if we knew what mu was. Okay, so x minus mu over 4. Okay, so essentially what we're trying to do here basically is find out what this is, mu, that will give us this. But what is this? Well, actually we know it to be this because that's what we're told to do. same proportion less. Okay, so the Z score here is going to be minus 1.25 actually. Z equals minus 1.25. Okay, from before. So that's something we can use. So essentially what we're going to do here is use all of this to create this formula here. Okay. So 1000 minus mu divided by 4 would have given us a Z score of minus 1.25. And if you calculate the probability corresponding to that, you would have got you would have got 0.1056, and that is the probability of the new that is the probability of W, the new machine's weights volume dispensed being less than the nominal amount 1000. Okay, so we're essentially just working backwards. So it works out that we get mu equals 1005. Okay, so that's the new amount. Okay, this means that 5 milliliters per carton could be saved at a cost. So that's what we're going down from 1010 to 1005. Okay. So a cost saving of per carton of 5 over 1000. Okay. So it's 5 over 1000, which is just how much we save per the unit amount that we sell, which is per liter is $1. Okay. So in order to recover the $200, how many do we have to sell? Well, we have to to spread out how many cartons. That's our savings, our denomination for savings. How many cartons? That's the saving amount, and how many cartons of orange juice do we have to sell to save $200? And working it out, you just a little bit of mental arithmetic and thinking through it, it actually means that we have 40,000. Okay, so we have to sell 40,000 cans of apple juice, to save the 200 quid. Okay, and that's the saving per carton. Okay, so we'll leave it there.